Welcome, ladies and gentlemen, to our next lesson on solving a system of linear equations. Today, in the blue 8th grade Big Ideas book, lesson 5.3, page 218 and 219. We already read it in class. We are going to learn how to solve a system of linear equations by using the method of elimination. I think you're going to like it. Now, elimination is called a couple other things. Sometimes it's called the addition method, and sometimes it's called the linear combination method. It's most commonly called elimination. So if you see them say solve it using addition or solve using linear combinations, it's the same thing. Okay? So we're going to read through these steps real fast. They're important steps. Those steps say that, one, when you're solving a system of linear equations, first, you might have to multiply, because it says multiply if necessary one or both of the equations by some constant, so that at least one pair of like terms has same or opposite coefficients. We talked about it. Don't waste your time multiplying and making them the same. You want to make them opposite. The reason is because in step 2, as we learn that if we add, it's real easy. When we subtract, we have extra steps. We add when the like terms are opposite. So we don't want to subtract. We'll learn how to, but we don't want to. Okay? And then when you solve the resulting equation for the remaining variable, you then substitute that answer from step 3 into one of the original equations, and you get your second number for your ordered pair solution. So right down here, I just mentioned it. We add when the variable coefficients are opposite. We subtract when the variable coefficients are the same. We don't want to subtract if we don't have to. It involves more work. So if we end up doing step 1, we're going to do it so that we end up adding. In other words, we're going to create opposite coefficients of like terms. All right? So let's do a couple. Solving a system of linear equations by elimination. And that's exactly what we want to do. We want to eliminate something. So we're going to use addition and sometimes subtraction. But remember, subtraction, we always follow the subtraction rules of same, change, change. So we will end up changing it to addition. Now, so that means I'm going to come to this example, this system of linear equations, and I'm going to add them. One of the reasons why it's called the addition method. I'm going to add them. And what I'm looking for is I'm looking for like terms with opposite coefficients. All right? So I look at the x terms. Well, I have an x and a 2x. They don't have the same coefficients that are opposite. But y has the same coefficient. They both have the coefficient of 1, and they have opposite signs. So the coefficients are opposite. That means we want to add. So right here is our opposite coefficients because they have the opposite sign. So now we're going to add. So we add like terms. X plus 2x, that gives me 3x. The negative y plus y, well, that gives me 0 y's. So 0 y's goes away. We don't need it anymore. And then 11 plus 19, that's 30. Solving our equation by dividing by 3, x is equal to 10. So our ordered pair starts off with x is 10. Now we take that 10, and what do? That's right. We take that 10 and we substitute it in either one of the equations, whichever one you want. I'm just going to put it in the first one. And I write 10 minus y equals 11. Subtracting 10 from both sides, I have negative y equals 1. I can't have a negative y, so I divide out that negative 1. Some of you know just to do that, you just change the signs. Y equals negative 1. I come over here, negative 1. My ordered pair solution for that system, 10, negative 1. I can verify that if I want to. We could spend the time plugging 10 and negative 1 into each equation and making sure that those equations are true. And I guarantee you they will be. Our next example. Hopefully you're now starting to look. 4x plus 8y we have equals 20, and negative 4x plus 2y is negative 30. We're looking for a variable that has the same coefficient, opposite signs. And right away, we see that the x term has 4 as a coefficient and one's positive, one's negative. We're going to add these two equations together to eliminate. So right here, 4 plus a negative 4 is eliminated because it becomes 0. 8 plus 2 gives me 10y. 20 plus a negative 30 is negative 10. Dividing by 10, y equals negative 1. Going over to my ordered pair solution, y is negative 1. Now I take that negative 1, and what am I going to do with it? That's right, I'm going to substitute it in, and I'm just going to put it in the first one. So now I have 4x plus 8 times negative 1 is equal to 20. All right? Adding that together, doing the math, 4x minus 8 equals 20. Add 8 to both sides. Using inverse operations in reverse order, for those of you who still need to, you could look at that equation and say I'm multiplying by 4 and subtracting 8. The inverse of that would be to add 8 and then divide by 4, if that's what you need. Okay? And so now 4x is equal to 28. Dividing by 4, x is equal to 7. Now, ladies and gentlemen, I'm going through these examples quickly. If you have to, you should watch the whole thing first. Some of you told me that if you pause as you're watching, that it makes you start over from the beginning. So maybe you just watch the whole thing first once, and then you go back and watch it again, writing everything in, hearing it a second time. Our ordered pair solution for this system was 7, negative 1. Going to number 3, 8x plus y equals negative 16. And negative 3x plus y equals a negative 5. Well, the first thing I'm looking for, do I have like coefficients on a like term that have opposite signs? Well, the 8x and the negative 3x, they have opposite signs, but the coefficients are not the same. Don't want that one. I have a positive y and a positive y. Well, I have the same coefficient. The coefficient is 1. However, the signs are the same. So we go back to what we said. If the signs are the same, we have to subtract. So I'm actually going to subtract these expressions, these equations. When I subtract the equations, I have to follow the subtraction rules of same, change, change. Meaning, the first equation stays the same. 8x plus y equals negative 16. Changing subtraction to addition. And then I have to change the sign of every term in the second equation. So this negative 3x becomes a positive 3x. This positive y becomes a negative y. This negative 5 becomes a positive 5. Bam. Now I'm adding 8x plus 3x, 11x. Y plus negative y is eliminated. And negative 16 plus 5 is negative 11. Dividing by 11, x is equal to negative 1. I come over here and I write my ordered pair. X is negative 1, and so I put that in there. I take my negative 1, and that's right. I've got to substitute it into one of the original equations. Doesn't matter which one we use, not one we rewrote, but one of the very original ones they gave us. So I'm going to plug it right in here. And I'm going to say that negative 3 times negative 1 plus y equals negative 5. And now I do the math. Well, negative 3 times negative 1 is positive 3. Plus y equals 5. Subtract, that's negative 5. Subtracting 3 from both sides, y equals negative 8. Done. Negative 1, negative 8 is our ordered pair solution. Going to our next one, negative 6x plus 6y equals 6. Negative 6x plus 3y equals negative 12. Once again, I look. I've got to either add or subtract these to eliminate. And I see that my x term has the same coefficient of 6, and they also have the same sign of negative. If they have the same sign, then we end up subtracting. And when we subtract, we follow the rules of addition. Same, change, change. Negative 6x plus 6y equals 6. The first equation stays the same. Our subtraction becomes addition. The negative 6x becomes a positive 6x. The positive 3y becomes a negative 3y. And the negative 12 becomes a positive 12. And now I add. Negative 6x plus 6x, that's eliminated. That makes 0. 6 plus a negative 3 happens to be 3y. 6 plus 12, that's 18. Dividing by 3, y equals 6. Start my ordered pair solution, put 6 in the y spot. Taking that y, substituting it in the equation, I'm going to put it right here. And I'm going to say negative 6x plus 3 times 6 equals negative 12. Negative 6x plus 18 equals negative 12. Subtract 18 from both sides. Negative 6x is a negative 30. Dividing by negative 6, x equals positive 5. My ordered pair solution is 5, 6. So the real key things here. We never had to do step 1. We never had to multiply. I'll do that in the next video. But what we did, we looked for the variable with the same number coefficient, hoping that it had opposite signs, because opposite signs mean we add them. If they had the same sign, then we subtracted them, we followed the same change rule, and then we added them, and that is easy. Let's go to our first quick write. Solving a system of linear equations by elimination. This one you can pause the video in just a second and make sure you write down these two systems, A and B. Make sure you're looking for the coefficient with the same, the variable with the same number coefficient, hopefully having opposite signs so you can add. If they have the same signs, subtract. I'll see you back here after you finish the quick write, take a quick snack break, and get ready to learn some more solving systems of equations by elimination.